All right, this is the second part of our topic 7. We're going to talk about Avogadro's number, what the mole is, and then molar mass. So it says most substances contain an enormous amount of particles. As a result, the unit of measurement chemists use to describe chemical quantities must represent an equally large number. A mole is defined as the amount of substance that contains as many basic entities as exactly 12 grams of carbon, which is the most common molecule, I guess, on Earth. We're not going to talk about isotopes. It says exactly 1 mole of any substance contains a constant 6.02 times 10 to the 23 basic entities of the substance. So every single element on the periodic table, 1 mole of it contains 6.02 times 10 to the 23 particles or pieces of it. Okay? This is referred to as Avogadro's number. So Avogadro's number is this number that 6.02 times 10 to the 23. That number is going to become, I guess, important when you're doing some of your calculations. There's a video here about Avogadro's number, and we can post that on the Google Classroom. So what is molar mass? Well, the atomic molar mass of an element is a weighted average of the mass of 1 mole of all the naturally occurring isotopes of the element. The molar mass of every element is listed on the periodic table. So our molar mass of all of our elements is an average of all of the elements that they can find on Earth that are, for instance, oxygen. So this 15.99, they may have found some that are 15.98, some that are 16.0, but that on average, they're 15.99. Okay, so that is known as the molar mass of oxygen. Okay. It says, for example, the molar mass of hydrogen is 1.01 grams per mole. So if we look at the periodic table, it tells us the molar mass is 1.008, or they've rounded it up to 0.1. While the molar mass of oxygen is 16.00, it's actually 15.999. We normally just always take it as 16, but it's really up to you. I don't care which one you use. So to figure out basically the mass of water, we have to take into account how many hydrogens there are, how many oxygens, and then times that by their mass and add them together. So might be a lot of things I just said, but in H2O, there's 2 hydrogens. So there's 2 atoms of hydrogen. Each atom of hydrogen weighs 1.008 grams, okay? In water, we also have 1 atom of oxygen. See, 1 atom. And we multiply it by the mass that we find in the periodic table, okay? So we do those multiplications, then we add those 2 together. We add the mass of the hydrogens and the mass of the oxygens to get the molar mass of water. Okay, so that's how you figure out molar mass. It's literally just using the periodic table and doing some multiplication and addition. All right. There's a video here showing you how to do that. You can look at that on the Google Classroom as well. But let's do some practice problems. So it says find the molar mass of each of the following elements. So if we're just dealing with an element, finding the molar mass is pretty simple because it's literally just what's on the periodic table. So for potassium, if I look potassium up, it's number 19. It's right here. It looks to be 39.10. So what is the molar mass of potassium? 39.10 grams per mole. right? So that's really important that you put those units there. Chlorine, if we look that one up, my periodic table, I guess I should use this one. I'm looking at the one in the class. This one's 35.45. All right. And then zirconium. Zirconium is number 40 in the periodic table, so let's find that. ZR, it's 91.22. Okay. So that's how we find the molar mass of an element. To find the molar mass of a compound, we've got to do a little bit more. So these ones are compounds. I don't really have the space. Sure I do. Let's do KBr right up here. So to find the molar mass of KBr, literally we just got to look up what's the mass of potassium, K, which is 39.10 grams per mole, and add it to the Br. And if we look up Br, we get 79.9. It's number 35 in the periodic table. All right, so that is that, and then we literally just need to add those two together to find out the total mass of KBr. So 39.10 plus 79.90. So when I do that out on my calculator, using the crazy calculators in the class, I get 119. Did I do that properly? Yes. And I've got, that's in grams per mole. Okay. So not too bad, just adding those together. Let's do the next one, which is CH4. So if we're going to do CH4, we first got to find the mass of carbon, and the mass of carbon is 12. I think it's 12.01. Let me double check. It is 12.01. I'll keep with my using the proper mass. So 12.01 grams per mole plus hydrogen. If we look up our mass of hydrogen, it is 1.01. It's number 1 in the periodic table. And then something to note here is that there's actually 4 hydrogens, because this number right there is telling us that there's 4. So we've got to take that mass and times it by 4. All right, so when we add this together in our calculator, we go 12.01 plus, and then I'm going to put a bracket and put 1.01 times 4, bracket, and I get an answer of 16.14. And that's grams per mole. Ooh. Didn't do my, there we go. There we go. So that is the answer to what's the mass of CH4? Well, it's 16.14, and the mass of KBr is 119. All right. And then the final one here is a little bit of a larger one. we can do that right below. This is AlNO3. This is a good one because it's got multiple brackets and numbers, so it'll give us a good idea of how you sort of figure out how many of each of the atoms exist there. So our first step here is to figure out what the mass of aluminum is. I see 26.98 on my periodic table. Double check. I just don't want to make you dizzy by going back and forth. 26.98, it's number 13 right here. Plus nitrogen. So there's no number below aluminum, so it's just one of them. For nitrogen, we've got 14. But again, I should double check to make sure I'm exactly right. It's 14.01. And because there's a bracket around this NO3, it's saying there's 3 of everything inside the bracket. So there's no number below the N, but there is outside the bracket. So we actually need to times this by 3. Okay. Oh my heavens. I'm too far over on the page. And then our oxygen, if we look that up, it's 15.99. And we've got to multiply that by, well, there's 3 right here, but there's also 3 outside. So that 3 outside the bracket is multiplied by this. And then we can, so 3 times 3 becomes 9. Okay, so that's how you do that. You just need to multiply that outside number by the little subscripts that are inside the brackets. All right, because there's actually 9 of them there. There's 3 in NO3, and then if there's 3 NO3s, that would be 9 in total. Okay, so now we can add all this together. We are good to go on this. So if we take this in our calculator, this is hopefully straightforward calculating. If you don't have a calculator at home, you can always use an online calculator. I can post one for you. If you have an iPhone, you can always use that, or any type of phone. I know on iPhones you can turn them sideways to get that scientific calculator, which is helpful. So when I calculate, oh my heavens, when I calculate all of this, I get an answer of 212.92, and that's grams per mole. All right. So that's how we'd figure out molecular mass, or molar mass, sorry. Now, how do we calculate mass and moles? Well, notice that the units of an atomic molar mass, grams per mole, allow us to convert between mass and number of moles using the following formula. So this formula, where it's little n, which is our number of moles, is equal to our mass divided by our molar mass. So this is a formula we can use to convert between moles and grams, basically. So an example, it says how many moles are found in 130 grams of H2O. So these are actually questions that I will take over to the notes section, just so that we can have more space. I can even write it out here. Forgot you can't write in the middle of words. Okay, so the first one here is saying how many moles are found. Do you want me to number these so that we can remember? That's number 1, number 2. It's actually number 3. Okay, so number 1 here is what we're going to do. It says how many moles are found in 130 grams of H2O. Okay, so our formula, just referring back to that, is N is equal to little m over big M, where this is the molar mass. This is the mass of our substance. So normally what they would give is in the formula. And this is our moles. So if we want to figure, this question is saying how many moles, so we want to figure out N. We don't know what that is. We do know what little m and big M is, or at least we can find it out. Little m is the mass of our substance that's given in our question, which is 130. Excuse me. And big M is our molar mass. So we can actually figure out our molar mass of water. We actually already did in that last, in the PowerPoint sometime. But I'll show you how to do it again. We'll refresh our memory. So if we're going to find the mass of H2O, we need to find 2 hydrogens plus 1. This is not a plus. So 2 hydrogens and then 1 oxygen. The mass of hydrogen is 1 and the mass of oxygen is 16. So if we add those together, it's 16 plus 2 would give us 18. So what's our molar mass here? It's 18 grams per mole. So in doing that, we've got N is equal to little m over big M. We actually have little m, which is 130, divided by our big M, which is 18. So if we calculate that out, we go 130 divided by 18, we would get, I'm using that annoying calculator, 130 divided by 18 gives us 7.22 repeating. And that would be moles. Okay? So if we have 130 grams of water, then that means that we have 7.22 moles. So there's a whole lot of molecules existing there. Let's try number 2. It says, what is the mass of 0.50 moles of H2O? So when we're doing our question, I like to write down like a little, I don't know, chart, I guess, of the things that they've given us. And what they've given us in this question is 0.50 moles. So they've given us the moles. They want to know what is the mass. So the mass is little m. That's what we're missing. But we can always find the molar mass, and we actually did that in the last question, which is 18, because it's water. So we can write that in there, 18 grams per mole. Okay. So now we got to take this formula, n is equal to little m over big M, and we've got to plug in the pieces we have. So we've got little n, and little n is right there. I'm going to write that. So we got 0.50. That's going to go into there, is equal to our little m, which we don't know, divided by our big M, which is 18. All right. So some of you might like doing it this way. Some might like doing it, rearranging the equation first. Personally, I don't rearrange the equation first. I just figure it out as I go. But you're going to have to be using that math that you learned and how to sort of solve for that missing piece. And if this is confusing to you, then I can definitely help you with solving for like missing pieces or doing some algebra refreshers. But it is really important that you have that math background to be able to do science. So here we've got 0.50 is equal to m over 18. So our job here is to move all our numbers to one side and our m on the other side, because that'll tell us what m is. All right. So for us here, we want m by itself. I shouldn't have used that color. We want m by itself, and we want to bring 18 to this side. So to bring it to the other side, what we've got to do is we've got to do the opposite of what it is doing in the original question. So this is m divided by 18. So if you remember, the opposite of division is multiplied. Okay? So to move 18 from the right side to the left side, we need to multiply. So what that means is we're going to go 0.05 multiplied by 18 is equal to m. Okay? So that gets rid of it on the right-hand side, and we're left with m by itself. That's good, because now we can go in our calculator, what's 0.5 times 18? It's 9. And maybe you already saw that. So what is the question's asking us, what is the mass of 0.5 moles of H2O? Well, the mass is 9. And I should put grams there. Okay. So that's how we calculate this out. Let's try number 3. Number 3 says, what is the molar mass of 0.03 moles of an unknown substance with a mass of 1.5 grams? So we've got a mass of 1.5 grams. We've got moles of what? Oh, we've got a molar mass of 0.03. So big M is our molar mass, and it's got 0.03. And then we've got 1.5 grams of it, I believe. No. Refresh on that one. I messed that question up. I wish I had it farther down here. basically what the question's saying is, what is the molar mass? So the molar mass is what we're looking for. So big M is what we're missing, okay? We do have our moles, which is N, and we do have our original mass, which I believe is 1.5, and this is 0.03, just to double check. Yes, okay. So this is what we've got. We are missing our big M, so we need to solve for that. So our formula here is N is equal to big M over little m. We've got our N, which is 0.03 moles, is equal to our big M, which we don't know, divided by our little m, which is 1.5 grams. So I think I have this mixed up. Wow, I'm doing a really terrible job at this question. My mind is not working the best today. So if you did it the way I was going to, that would mess you up. All right, so now that I've got this properly put in the equation, we need to solve for big M. Something to note, the big M is on the bottom. That's going to be really difficult. So what I like to do is bring big M to the top. So this is like a two-step one. We're going to have to bring this one over here. So the same thing, it's divided by M. So we want to multiply the other side by M. I'm going to get rid of that mole part because it might confuse us, and the grams, just the numbers. And that is equal to 1.5. Now we need to get rid of the number that is in front of the M, and it's multiplied by M, right? Whenever you see something beside a letter like this, that means multiplied. So the opposite of multiplying is divide. So we divide by 0.03, and we got to do that to both sides, because 0.03 divided by 0.03 will, OMG, get rid of that, and then we're left with whatever 1.5 divided by 0.03 is, 50. So big M is 50, and that is grams per mole, because this is a molar mass. So this thing said it was an unknown substance, and its molar mass is 50. So we could actually figure out probably what that element is by looking for the thing that's 50 on the periodic table. And to be honest, I don't see something that's 50. I see something that's 50.94, which is probably our best bet, which is vanadium. So this element, this unknown element, would be vanadium, because vanadium on the periodic table is 50.94 grams per mole. So likely vanadium would be what that unknown substance is. Okay, so that is that part. This is the end of chemistry. That's all that we are going to do in chemistry, I believe. Let me double check. Yeah, that's the end. So you should be able to do the questions that go along with topic 7. And then we will have a quiz on this probably by Thursday. I'll give you a review for it tomorrow. And then you'll have until next week to finish that quiz up. Okay? Sounds good, and have a great day.